Welcome back. In this module, we'll be talking about logarithms. Recall from days 7 to 8 that given the expression a to the power of x is called the power, index, or exponent of a, and a is called the base. However, an exponent is also called a logarithm. In particular, if y is equal to a to the power of x, then the power x is called the logarithm of y to the base a. Here are some examples of logs to the base 2. For instance, log 4 is equal to 2, since 2 to the power of 2 is equal to 4. Log 8 equals 3, since 2 to the power of 3 is 8. In contrast, the log of 1 on 8 is equal to minus 3, since 1 on 8 is equal to 2 to the power of minus 3. Similarly, here are some examples of logs to the base 10. The bottom line is, when you're calculating logarithms, you're simply calculating powers. The log button on your calculator calculates logarithms to the base 10. So for instance, pressing the log button followed by entering 1000 will calculate the log of 1000 to the base 10. This is 3, since 1000 is equal to 10 to the power of 3. Of particular interest to us is the LM button, which calculates logarithms to the base e. For instance, inputting ln5 on your calculator should give you roughly 1.61, corrected 2 decimal places, since 5 is roughly equal to e to the power of 1.61. Terminology-wise, logarithms to the base e are called natural logarithms. A special property of logs is that log 1 to any base is always 0. This is because we know from day 7 that any non-zero number to the power of 0 is always 1. Moreover, recall from day 8 that any exponential function of the form y equals a to the power of x outputs strictly positive numbers for all x values. This means that it would not make sense to compute the logarithm of 0 or any negative number. Indeed, if you try this on your calculator, you will find that you'll get an error message displayed on the screen. The following are some useful logarithm laws, commonly used to manipulate algebraic expressions involving logs, and are true for logs to any base. The first law states that the log of the product of two positive numbers is equal to the sum of their individual logs. The second law states that the log of the quotient of two numbers is equal to the difference of their individual logs. Finally, take a look at the third law, which effectively says that the power of a can jump in and out of the log. Here's an example of a typical problem that requires you to use the log laws to simplify an algebraic expression that involves logarithms. The first step involves moving the power of x plus 1 to the outside of the log, using the third law. We can then combine the two separate logarithms together under a single log by using the first law in reverse, which then gives us the final answer upon simplifying the inside of the log. Alright, now it's your turn. You should pause the module and have a go at the following practice questions. Here are the answers. Here's a brief summary of what we've learned in this module.